Hello and welcome to the second video describing my hot wire foam cutting software. In the first video I showed you how to simulate cutting a foam wing panel, and today I'm going to walk through the steps of connecting the software to an actual hot wire foam cutter. So the first thing we need to do is look at a typical foam cutter setup. It's two frames, a left and a right, and each frame has a horizontal or X-axis stepper motor and a vertical or Y-axis stepper motor. I use the Z-axis as the spacing between the two. So in order to control this, we need to make 4 independent stepper motors move, and the way we're going to do that is with a typical stepper motor controller, something like this. The key thing is it has this simple step and direction control interface, which means that there are 2 digital input lines to this controller that move the motors. The first one is the direction, and whether or not that's high or low determines the direction the motor is going to move on each step that it takes. And then the step input triggers on either a rising or a falling edge depending on the characteristics of the controller, and I'll show you in the software how you can adapt it for either one. But basically, whenever there's an edge on this pin, the motor is going to take a single step. The other configuration details things like how much current and micro stepping and things like that depend on how you have your foam cutter set up. So that's kind of determines how you need to connect this. But this step and direction interface is pretty common, and so a wide variety of stepper motor controllers will support that. And what that means is that we need 8 digital I/O pins because we have 4 independent stepper motors and each one takes 2 pins. So in order to connect a PC to that, in the past people have done things like use the parallel port, but of course there aren't really parallel ports on PCs anymore. The other thing is that Windows, Linux, Mac OS X, they're not real-time operating systems, which means you can specify a timer that runs really fast, but the operating system could take over for several hundred milliseconds and not run your timer and then come back and run it several times in a row faster than you thought. And the overall result is that you're going to get a poor foam cut. Basically, the quality of the cut really depends on the ability to keep the wire moving at a specific constant speed all the way through. And so the way I've decided to do that is to use a special single board computer to drive these digital I/O pins that's connected to the PC. So I chose this one from a company called Olimex. It's pretty cheap, 13 euros. It's about 17 or 18 bucks in the US from a variety. I think Mouser carries them, DigiKey, and a bunch of other people, so you shouldn't have any problems finding it. And essentially you connect this board to your PC via USB, and then this prototyping area over here brings out all the I/O pins, and there's a wiring diagram so that you can solder wires or put a header on and make connectors to connect this to any sort of stepper motor controller that has this step and direction input. So there'll be 8 of them. The other thing, which I'm not really going to go into today, is there are also 8 digital inputs programmed in here to work as limit switches. So if you wanted to, you could have high and low limits on each of the stepper motor axes, and that would keep the motor from running up against the hard stops when they're activated. And again, that all comes out on this prototyping area, and you can connect those or not connect those depending on whether you want to use that feature. So let's look at how we program this board, because the first thing we need to do in order to make this work is to get the correct software loaded onto it. So here's a closer up picture of the board, and you can see there's a jumper here. You can see one of the pins is exposed and there's another pin under here. If we pull this jumper off and move it over so that these 2 pins are jumpered together, and then we plug in the USB port, what we'll find is that the board shows up as a regular USB mass storage device. And I've done that already. And inside there, you'll just find something called firmware.bin that's always 32 kilobytes. That's the size of the flash memory. So before we can put anything new on the board, we have to delete this. So I'm going to go ahead and do that right now. And to program the new firmware on the board, you need to find the folder where you installed the foam cutting software originally, and you'll see that it has a folder called device. Inside that folder, there's the name of this device in case we ever port it to something else. And inside here, you'll find another .bin file that has the firmware in it. So all you need to do is drag that over to here, and that's the end of the programming process. Don't bother trying to eject this because it'll fail. It doesn't support that. You can just close this window and then unplug the board. After you unplug the USB connector from the board, you want to make sure and clear that jumper so it doesn't go back into bootloader mode, and you plug it back in, and now it's ready to be a foam cutter. So I've done that, and now let's show how the software actually makes use of it. So we're going to go back to the top level here, and in our bin directory, if you remember, here's the foamcut GUI.exe, so that's the program we're running, and the familiar main window comes up. And so now what we need to do is we need to set up our controller. So the setup dialog comes up. Oh, I did forget one step. When you first plug that board in, Windows is going to ask you for a driver. The board is a USB to serial converter, but it does require a driver on Windows. You won't need that on Linux or OS X. For Windows, if we go back to that folder where the firmware was in Device, there's a driver folder, and inside here is the .inf file that you'll need. So you can go through the regular Windows process for installing a driver, and when Windows gets to the point of asking you if you know where the driver is, just say yes and point it to this folder, and it should install the driver. And then if you go into Device Manager or some terminal emulation software, you should see a new serial port show up. So I've already done that on this PC, that's why we didn't get that dialog box. So anyway, getting back to the foam cutting software, inside the setup dialog, there's a couple things we need to do to tell the software about our particular foam cutter. So the first one is the X and Y step size. The assumption is that the lead screws on the left and right are identical, but you might have used different ones for the X axis and the Y axis, so you can independently set the step size here. And again, if you remember from the first video, as far as units are concerned, it's the user's responsibility to just make sure all the units are consistent. So I'm working in inches. My lead screws use a 1,000th of an inch step size. If you're working in millimeters or you want to do things in meters, you put those numbers in here, and you just need to make sure that when you import the data files, the coordinate system you use is consistent everywhere. The other place where there's a length is this frame separation. So if we go back to the picture, you recall there's a left and a right frame here. When these are bolted down, there's some distance between the two of them, and the software needs to know that, and that is what the number is there for the frame separation. So other things you can control, the maximum steps per second. This is really just a check, so as you specify speeds, the software will tell you. Stepper motors will start to miss steps if you try and drive them too quickly, so it's important that there is a limit because there's no feedback on the position. So if you're missing steps, you'll just get the wrong shape when you finish the cut. The other thing is active low steps. So this is what I talked about earlier, the rising edge or falling edge to trigger a step. The assumption is that it's a rising edge that triggers a step. If it's actually active low or a falling edge that triggers the step, you just check this box. In the case of my stepper motor controller, it's active high, so I'm going to leave this unchecked. Finally, I give you the ability to reverse each of the 4 stepper motors independently. So you can, of course, change the direction a stepper motor moves by rewiring it to the driver, but if you've already made connectors and you have a harness and everything and you don't want to do that, you can use this to make sure everything's moving in the same direction. Now, the final thing you need to do is you need to find the COM port that the device showed up as when you plugged it in. I happen to know that mine's COM3. This will list all the available COM ports on your machine, which is usually going to be a small number now because they're not really standard feature on most PCs. So I'm going to pick COM3. You can see the move button is now enabled, so that means we successfully connected. So I'm going to say OK and close that. Excuse me. At this point, we are connected to the stepper motor driver, and we can use this move dialog, and I can click on these buttons, and now the actual hardware is sending those signals to the motor controller. I'll make another video where I actually show my setup with the stepper motors connected, and you can see the whole thing in operation. But that basically summarizes the process of getting configured and connected to actual hardware that can move a hot wire for cutting foam. Thank you.